Let us quickly start our today's topic, guys. Okay. Welcome. Hi, my name is Israr. I'll be taking your NumPy and your Pandas classes, right? So, NumPy, your Pandas, as well as your visualization libraries such as Matplotlib, as well as your Seaborn. Okay. So, these are the topics which I'll be covering for the upcoming days, right? And uh, yeah, of course, for this particular library, we require some extensive practice, but we'll start with the theoretical part and then we'll come to the practical part for this particular libraries over there, right? So let us quickly start our topic, guys. Okay. Okay. Now, first thing is NumPy, right? So we'll be starting with the first library, something called as NumPy. Okay, so this is unlike your other Python functions, guys. These are not your built-in functions, right? So this is something which are external, right? So not every Python, not every system might have NumPy, Pandas, Matplotlib, or any of these particular libraries installed, right? So first thing is, before we start understanding the library, as well as before we start working on it, what you guys have to do is basically you have to install this particular library. Okay, so if you guys are using Anaconda, or let's say even a Google Colab, right? So these libraries might be there by default. Okay, so while installing itself, it might get installed. But again, if you guys are using some other editors, this might not be available over there, right? So hence, what you have to do is first you have to install all of these particular libraries. How do we install it, right? So it's pretty simple. Just open Google and search for that particular library name. Let's say in this case, we are trying to install NumPy space PYPI, any library name space PYPI. Okay, search for that particular library name and then open the first link, right? So open the first link. Okay, here you'll be able to get an option for you to install this library. Notice this one. So pip install numpy, right? So if I wanted to, let's say, install pandas, right? So it was going to be pandas space pypi, like any library name followed by pypi, right? So just install this particular library if it is not available. Okay, but if you guys are using Google Colab or Anaconda, you might not need to do it because see, in my scenario as well, it is already installed. Okay, so first thing is install, right? So let me know if you guys, everybody is able to see this in your screens, guys. Then I'll proceed. Open a new tab, library name space pypi. In Google Colab, you need not. Just confirm me once done, then I'll proceed.
Can you go to that page, that Google page?
Yes.
If you have to click on this, right, NumPy.
Yeah, the first link, pypi.org.
Okay, I'm getting then this NumPy 2.3.4 pip install.
2.3.4.
Yeah.
Yeah, so copy this one. This is the latest version of NumPy. Copy this one, come over here, paste it, and execute it.
Okay.
I'm using Visual Studio Code. I did the same and it is getting installed.
Yep, it will take. Uh, yeah, especially for the people who are using VS Code or PyCharm or IntelliJ, right? So this is for them, guys, right? So if you guys are using Anaconda, for you guys it might be installed. But again, anyhow, just confirm it once before we proceed. Okay, let it get installed in the backend. We'll proceed with the theoretical part, right? Okay, so what exactly are these libraries used for? Okay, so these libraries are used for our data handling, right? So there are two libraries. One is NumPy, and then the second one is for Pandas. Okay, so Pandas is something which is actually used for only data handling, right? So basically, let's say over here, if you want to add a column, delete rows or access rows or basically whatever it is, right? So that is the use of the library, something called as pandas. But what exactly is NumPy used for? This particular library is actually used, okay, so the name itself will give you an hint. Okay, so the full form of this particular library is numerical Python. Okay, so numerical Python, right? So the full form itself will give you an idea that, okay, this library is only used to do what? Is used to perform mathematical operations on our data. Okay, so that is the use of the this particular library. For an example, let's say over here you have a column, you have another column. So you just want to do what? Best perform addition for this element to element, right? And I want to store the results. So just to perform even a simple addition or subtraction or whatever it is, right? We use something called as NumPy to perform mathematical operations on our data. So that is the use of NumPy. Okay. Now you can ask me, hey, why do we use NumPy? We can also perform all of this mathematical operations in our core Python as well, right? So what is the use of NumPy as a library, right? So see, there are various reasons. First thing is the syntax is pretty simple, okay? But there is one more advantage. This library is not written in Python at all. This library is written in some other language. Anyone has an idea what exactly, which language is it written into? NumPy, let it be pandas.
Since you're saying data maybe around SQL.
No,
Okay.
it's not. Regex,
C++.
it is actually written in not even C++. It is actually written in C. Okay, so this library is actually written in C language. Okay, so now there is an advantage. Okay, now the advantage is basically what? Okay, so for an example, let's say any Python code, you are writing down a code. First thing is what happens? First thing is it gets converted, correct? So whenever you're trying to execute a Python code, it gets converted into whatever binary format, right? So let's say a format where the machine understands, right? Then again, after that, your kernel understands it. And then again, once your kernel processes the particular thing, and again it gets converted, and then you will be able to see the output, right? So this is what happens in case of our Python. But on the case of C, this scenario does not happen. Whatever code which you are writing down, the same code can directly be understood by something called as your kernel, by us nothing but our machine. And whatever output, again, it need not convert, you will be able to directly see this particular output over there. So that is an advantage. See, there's no language until this particular date that is actually faster than C, right? So any code that is written in this particular language, you will have an output very quickly. For an example, okay, I'll show you one scenario. Okay, so I know you might not understand the code right now, but just try to understand the logic, guys. Okay, what I'm trying to explain, right? So for an example, yes, again, I have a question that I can perform any operation in case of our core Python as well, right? So let's say I'll write down a code. Okay, so let's say I'll even try to use a type of a stopwatch. Okay, let's say import type. Okay. Now, let's say for an example, there are two lists. Okay, so L1, and let's say there is one more list. Let's say that is, I'll just call it as, let's say L2. Okay. So I'll take a little huge number, let's say range of, let's say something like this. Okay. And similarly, same set of elements, I'm going to do what? I'll be trying to put it inside L1 as well. Okay. Now, let me calculate the time before. What was the time, right? So let's say T1 is equals to, let's say, time dot time. Okay. And I'll try to calculate, I'll try to perform what? Basically, I'm trying to imagine one column and there is a second column, right? So these are two columns. I'm just trying to perform element to element wise addition. That is what I'm trying to perform right now, right? So in that case, how do we do in Python, right? So let's say over here you have an empty list. Okay, so and let's say this is an empty list. I'll start a loop. Let's say for I in the range of, let's say, length of any one of this particular list. Okay, after this, let's say I'll just do what? Let's say over here, whatever empty list is present, I'll try to dot append L1 of the values of your I plus L2 the values of your I, right? So that is what I'm trying to perform. That's it. A simple operation, guys. Okay, so basically what this the addition of those two lists element to element wise. That's it, right? So now once done, let me try to see what was the time actually taken for this particular operation to be done, right? So let's say over here, after this time, the current time minus the time taken for this one, right? So let me just try to print this over here. Okay, now let me execute this. Let us see in core Python, I'm just performing addition of this two list over there. That's it, right? So no other complex operations at all. Let me execute this. Let me see how much exact time it actually takes to perform this operation. It will take somewhere around 7 to 8 seconds to perform this operation. It's still running. It's still running. Okay, so if you look closely, somewhere around 33 seconds it has actually taken for it to perform this particular operation over there. Now, let us see or compare the same time or for the same set of elements. If I want to process this data in NumPy, how much time will it actually take? Right? Let's say over here, the same code, if I wanted to do it in our NumPy, it would have been almost similar, but a small change, right? So let me take this as, let's say, np dot arrange, same set of elements, and over here also let me try to take this over here. Okay, in NumPy, not just this, even your syntaxes actually becomes very simple. Okay, so let's say in this same scenario, if I wanted to perform addition element to element, I need not run a loop at all. So I can directly go ahead and do it like this. Okay, now if I execute this, okay, so same set of elements. If you look closely, same set of elements. If I am running this code, let me see how much time is it actually taking, right? So it is, if you look closely, 1 point something like this second it has actually taken for it to perform this operation. Now you tell me. So here while learning, okay, you might be maximum what, 15, 20 elements, something like this you'll be dealing with, right? But when you're working with an actual data, you'll be playing around with terabytes of data over there. So don't you think that even a millisecond save will actually affect your processing time? Yes or no? Yes, right. So that is the use of our NumPy as a library. Clear everyone, why do we require NumPy? So see, it is a pretty simple library just to perform mathematical operation. Mathematical operation can be anything: addition, subtraction, your exponent, your power, your all any of this, right? So, but why actually NumPy? Even our core Python, we can do it, right? So, but the thing is here, the processing time is actually very much reduced over there. That is why we use something called as NumPy as a library. Okay, now let us now understand what are all the things which I have done and everything. Let us try to understand this. Okay, so yes, first thing is it is written in C. The speed of the performing calculation is actually comparatively very faster. Okay, what is the second advantage? Here, second thing is the syntax is actually pretty simple. If you look closely, the syntax is very simple for our mathematical operations, at least, right? Then, but there is one more advantage. In NumPy, you can actually process this can be used. So basically, I'm talking about this library can be used to perform, or let's say to compute and process not just something called a single dimension. What we are dealing over here is basically single dimension data. Not just this, single as well as your multi-dimension data. Okay, so multi-dimension, something called as arrays is what we refer it as over here. Okay, what is the meaning of array? What is the meaning of single? And what is the meaning of multi-dimension? We'll understand this, guys. Just give me some time. Huh? So not just this, basically not just single dimension data, it even helps us to process our multi-dimension data as well. Okay. Then the last point is, okay, if that is the scenario, if everything is that easy as well as if it is quicker, why do we need another libraries? Why do we need pandas to handle the data? Why can't we do everything in NumPy itself over there, right? Right. So, but there is a problem in NumPy. Okay, so there's a problem in NumPy. The problem is here. Okay, I'll write down the point. Let's see who understands this point. All the arrays should be an homogeneous data. Homogeneous data. Okay, first question. What does this particular point mean? It is the same data type, correct? Right. So the problem in NumPy is, yeah, see, everything is good, but there is a problem. There is a limitation. The limitation is basically what? So let's say over here, for an example, imagine an Excel sheet. Then you will have a clarity. One column can be a string, second column can be an integer, third column can be a bool, and fourth column can be again a string. So basically, we can have different data types over here, correct? In an Excel sheet. But the problem in NumPy is this will not be supported in case of NumPy. It will not be allowed. So let's say over here, one value is string. Everything becomes or tends to become a string. So that is the limitation of our NumPy. That's why we have other libraries, pandas. We have PySpark to handle the data, right? So that is a limitation. This library is purely used for mathematical operations. Over there, clear? Okay, now let us proceed, right? So once you have installed this, right? So unlike our functions, the basic functions which we have studied, for an example, let's say this append, etc., right? So all of these functions are built-in functions of our Python. So unlike our built-in functions, this libraries, once you have installed it, the second step what you have to do is basically you have to import it, right? So import NumPy. Okay, now, yes, you can import a library as it is. You can import and you can use in numpy dot whatever the function name, right? But again, the problem is again and again, you have to write down complete numpy. What we can do is we can give an shorter alias, but the commonly used alias for this library is what? NP. But it does not mean that you can only take NP. You can even take hello world also. You can even take hello world as well. It is possible. You can take anything as an alias. But the common alias used is what? For NumPy, it is NP. For pandas, it is PD over there. Okay, first thing is after installation, you have to import it in order to work on it. Clear? Okay, now here I had written a point, something called as arrays, right? So something called as arrays. Now, first question, before we understand single and multi-dimensional data, the question over here is what exactly is an array? Anyone who can help me out?
A series of data.
A series of data. Okay. Now, in simple words, let's say I'm very fresh to programming, right? In that scenario.
One row of Excel.
Yeah. Okay. Yeah. So an row of an Excel, correct. That is best method of imagination, guys. Then anything else? Collection of data. Yeah, collection of data, series of data. Okay. But for me to understand single and multi-dimensional arrays, how can you explain this? It's pretty simple. Okay. Now imagine something like this, right? So remember in our mathematics, I think in our class, I don't remember the exact class when we actually started, right? So in our mathematics, we have studied a concept, something called as matrix. Do you guys remember? Anyone? Anyone here who haven't heard about matrix at all? Okay. Now, that same matrices, in case of our programming languages, what you will be referring to as something called as, in our case of our programming languages, you will be referring it as something called as arrays over here. Okay, so it will be very easy for us to understand it. Then, same concept of this matrix in case of our, once you are into deep learning, right? So that's where in our deep learning, the same arrays, that time we'll be referring to this as something called as tensors over there. Okay, so tensor, right? So, but eventually we are talking about something called as matrix itself in the backend. Okay, so try to imagine it in this manner. Now, the question is, what exactly is this one dimension data? What is multi-dimension data? So imagine it something like this. Let's say over here, okay, so imagine an Excel sheet, one single row of an Excel sheet, or else, okay, imagine it something like that, right? So see, here there are multi-dimension data. I'll try to give some example. Right? One dimension we have two-dimension data, then we have your three-dimension data, etc. Right? Okay, one-dimension data is basically what? So imagine a row or a column. Imagine a row or a column in case of an Excel sheet. Okay, in case of our core Python, what? It is nothing but imagine a tuple or a single list. This data is something which we are referring to as something called as one dimension data. Okay, what is two dimension data then? So imagine multiple rows and multiple columns in an Excel sheet, right? So here you have multiple rows and multiple columns in case of our Excel sheet, right? So same data here you will be referring to as something called as two dimension, because you have two axes, X and your Y axis, right? So two dimension data. Okay, so but in an actual programming, how does it look like? So it is nothing but our simple matrix. Okay, so imagine something like this. So one matrix. Okay, so this is our two dimension data. Okay, then what exactly is three dimension data? It is nothing but a cuboid, right? So over here, something like this type of data, right? So cuboid. Okay, so here you have three axes, X, Y, and your depth, right? So okay, how do we represent this type of data in case of our programming? Okay, imagine one matrix repeated above the above, something like this. Imagine something like this, right? So this type of data we are referring to as what? Something called as three-dimension data, where we have three axes over here. That is what I am referring to as something called as multi-dimension data, guys. Clear? Okay. Now I'm going to go a little slow initially so that we all have an idea. Then of course we'll pick up our pace, guys. Okay. Okay. So now, okay. So this is matrix once more. Sure, done. Okay. Now, for that, see, multi-dimension. We have one dimension, two dimension, three dimension, four dimension. It is very difficult for us to imagine. Okay, so we have multi-dimension data. In NumPy, I think you can even process until 10 dimension of data over there. Okay, processing it is possible. Right now, the question is how do we imagine it, right? So one dimension, imagine one single row. Okay, so you have an Excel sheet. In that particular Excel sheet, you are capturing one row, or let's say one column also, at least anything, right? So this type of data, okay, is referred as one dimension data. So in Python, how do we represent this? So imagine either a Python list or a tuple, simple list or a tuple, right? So this type of data, we are calling it as something called as one dimension data. Then what is two dimension data? Something which has multiple rows and multiple columns. Okay, now if you take an example of an Excel sheet, there will be multiple columns and there will be multiple rows, correct? So this type of data, we are referring it as something called as two dimension data. Okay, now, but again, how do we represent this in case of our Python, right? So it is nothing but our matrix. Okay, so imagine a matrix of whatever, right? So something like this, right? So whatever size, it can be of any shape, right? So 2 cross 3, 3 cross 4, whatever it is, right? But again, imagine a matrix. Here you can tell the matrix as something called as our two-dimension data. Okay. Then what is three-dimension? Nothing but a cuboid. So imagine multiple two-dimension matrices repeated one behind the other. So here you'll have a clarity. Okay, simple cuboid you imagine, right? So this type of data we are referring to as something called as three-dimension data. Clear? Okay. Now step two. Yes, we understood what does it is. Okay, while imagining it is possible. Okay, but the question is, how do we actually create it? How do we create a matrix? How do we create a one-dimension array? How do we create a two or three? What is the syntax, right? So it is pretty simple, guys. Now, if you want to create it manually, there are a couple of methods. I'll try to take you most of them what we commonly use. Okay, so creating of your arrays, right? I'll take you guys through most of this particular method, but again, let us go step by step, right? So let's say now, step one. Here you are trying to create an array or any dimension array manually, right? So which function we use? We use something called as array function inside NumPy. Okay, so inside NumPy we have something called as array as a function. Okay, now let us see how do we actually create it, right? Let's say over here I have a simple Python list. Okay, so something like this, some random data is present. Now we all know that this is nothing but our Python list, right? So let me just print the list and then the type of our list. Okay, now the question is, okay, so this Python list, how do we actually convert it into an array? Okay, here you are creating the data manually. You're basically, you have a Python list or a tuple, you're converting that into an array. So which function we use? Basically arr is equals to, I'll take np dot array as a function. Okay, here this is where you can go ahead and you can pass your particular list. How does an array looks like? So it looks something like this. Okay, so this is nothing but our Python list. This is nothing but our NumPy array over there. Okay, so this is something called as one-dimension data. I'll show you how do we actually find it out, right? So this is how you can create an array. Okay, so one dimension, it is pretty simple. Nothing but our Python list or tuple you can directly provide over there. But the question arises, how do we actually create a two-dimension data? What exactly is the syntax for us to create a matrix, which I'm referring to, right? So imagine it in this manner. Let's say over here, I have one matrix. Uh, let's say I'll just put some random values, 2, 3, 4, 9, 10, and 11. Okay. So something like this. Imagine this is the matrix which we have. Now the question is, how do you write down this type of matrix in this particular syntax? Is there any in your keyboard? Is there any big bracket or something like that? There's no, right? So how do we actually write it down? So this is where you use the concept of nested list, which you have learned in our Python, core Python. Nested list is basically what? A list inside a list, correct? So that is how you create an NumPy array. Okay. Now, okay, so this matrix, if I want to convert it into a Python syntax, right? So how do we do it? So write down. It's pretty simple, guys. 2 comma 3 comma 4 is the first row, correct? So first row, then the second row, that is what? So second row is what? 9 comma 10 comma 11, something like this, right? So this is the first row and this is the second row. This whole thing will be packed inside another list over there. This is the syntax for you to create a two-dimension data. Pretty simple. Okay, I'll just comment this out and I'll show you. So the matrix which you are able to see on the right hand side, notice I'm able to create that particular matrix. Okay, now I want you guys to help me out to create one matrix. Okay, so just a minute. Then help me to create 1, 2, 3, 4, 5, and 6. Okay, first question. Hey, how do we calculate the shape of a matrix? Is it rows into columns or columns into rows? So for an example, yeah, in this case, that is how many rows are there? 3 cross 2, right? So 3 cross 2 matrix. Okay. Now help me to convert this 3 cross 2 matrix so that I can write it down in our core Python. That's it. Can you guys help me to do it in the chat box? Yep. Okay. Harshita, your syntax is wrong. Mohan Krishna, you're correct. Tarun, you're correct. Arunima, you're correct. Sneha, correct. Vikas, you're correct. Harshita, check one syntax. I think you have missed bracket exactly. Okay. Now, how do we write it down? Of course, I'll just copy any one of you guys' code, guys. Okay. So let me copy and paste it over here. Okay. Now, if I execute it, yes, the matrix which you are able to see on the right hand side, I'm able to convert that into a NumPy array. Okay, that is the array which we are able to see. Okay, now one question: is this data a three-dimension data or two-dimension data? What do you think? How many axes do you think which we have over here?
2D.
It is a two-dimension data, common, right? So, but again, one question I'll try to ask is how come 2D? So we have one. See, this is one. This is two. This is three, right? So there should be three-dimension data then. There are three lists inside this one, right?
No, the other data is just spanning over the next dimension, not the third dimension.
Yeah,
Right.
exactly. So this array can be even, you can even have three multiple, even million rows as well, correct? So it does not mean that okay, this dimension of the data change over there. You can have millions of columns also, right? So it does not mean that okay, the dimension of data is something which you are calculating from here, from the by counting the brackets. No, this is not how you do it. Okay, so there is a different method of finding out the dimension in a glance. I'll show you. Okay, now okay, two-dimension data is something which we created in this manner. Now let us first understand how do we actually create a three-dimension data. That is also going to be very simple. Okay, now let's say over here I have one matrix. For an example, let's say 1, 2, 3 and 4. Okay, so let's say this is one matrix which is in front of me. Then there is one more matrix in the backend. Let's say over here that is 5, 6, 7 and 8. Okay, so something like this. Okay, now there can be infinite matrices like this. Okay, but I'm just giving an example of two right now. Okay, now over here, this is nothing but our three-dimension data, which I gave you with an example. Right now, the question is how do we actually write down this type of data? That is also pretty simple. So it is nothing but okay. So how do we write? Let's say if I am trying to write it down manually, right? First row that is 1 comma 2. Okay, then again second row for the first matrix, right? That is 3 comma 4. Okay, so this whole thing is a single matrix, correct? So this is one matrix. This is a one two-dimension data. Notice one matrix I have created. Okay, after this there is another two-dimension matrix. Okay, let me just copy this and paste it. Okay, and the elements, let me just change the number of elements. So that is 5, this is 5, and let's say this is 6, 7, and let's say this is 8. Okay, and this is okay. So this is our two-dimension data. This is the second two-dimension data, and this whole thing is wrapped around one extra bracket. Okay, so this, if I run this code out, the matrix which you are able to see on the right hand side, this is how I have written it over there. This is how we write down a three-dimension data. Clear? Okay, now just for trying purpose, help me to create I'll just write it down. 1, 2, 3, 4, 5, and 6. This is one two-dimension data in front of me. Let's say over here 7, 8, 9, 10, 11, and 12. Okay, so let's say this is another two-dimension matrix in the backend. Help me to convert this matrix in this syntax so that our Python can understand it. Try it out, guys. Try it out. Exactly. Arup, I think there is one square bracket which you missed at the end. Sneha, you're correct. Venkat, you're correct. Because you're right. Oh, okay. I think this is cut shorting. The chat box is cut shorting the last bracket over there. Okay, so let me just copy any one of you guys' code, paste it over here, and if I run this code out, of course, what you are able to see matrix on the right hand side, we have able to convert it over there so that our Python can understand it. Okay, pretty simple, right? So nothing but our two-dimension data is what? A rectangle or a square, right? So this is what we are referring to as two-dimension data, right? So if you look closely, a type of rectangle. If you look closely, a type of a square or something like that, right? Now cuboid, a cuboid is basically what? So let's say there's one square and then there is another square. Just try to imagine this, right? So something like this type of data, right? So something like this type of data is our nothing but our matrix, which we are trying to write it down over there. Clear? Okay. Now hold on. Now the question is, okay, now stop working, guys, just for some time. Now the question is, do we, if I want to find out, okay, so I'll just take this matrix as an example for now. Then we'll come to three-dimension data. Okay, so yeah, yes, we have this particular array which we are able to see. Okay, so few important attributes. Okay, now yes, we are able to see this array. Okay, so I have a simple question. So we all know what dimension data it is. Currently it is two-dimension data. Awesome. Okay, so second thing. Okay, so you have three questions now. So first question is, totally how many elements are present? Total number of elements in the array. Okay. Then again, second question what I have is basically the shape of an array. What is the shape of an array? I want to find out. Then the third question is, what is the dimension of the array? Okay, so three questions, right? So total number of elements. There are, of course, here the data is very simple. Literally we can count. There are totally 6 elements. But what if the data is very huge? Millions of rows, millions of columns. At that time, the same thing becomes a little difficult for us to answer, right? So we need not worry. So there is a direct function, there is a direct attribute that will help us to find out. That is arr.size. Okay, remember this attribute. Size will give you the total number of elements inside your array. Okay, step 2. Okay, how do we find out the shape of an array? Okay, so now I'm talking about 2 dimension. 3 dimension it will change a little bit. For 2 dimension we all know that is rows into columns, correct? So this is what 3 rows and 2 columns, right? So if I want to find out the shape of an array, so arr dot shape is an attribute that will help you to understand it. This will give you for 2-dimension data, it will give you the output as what? 3, 2. 3, 2 is basically what? Rows, columns over there, right? So 3 rows and 2 columns. Okay. Now, what is the dimension of this particular array? That is nothing but our print arr dot ndim is the attribute that you can actually use. Here it is nothing but our this is nothing but our 2-dimension data. Okay? So I'm able to find out over here. Okay. Now the same thing. Let's say if I complicate this with a 3-dimension data over here now. Okay, so something like this. For this array, what will be the outputs? Okay, so what will be the outputs? First thing is total number of elements. 6 plus 6, 12 number of elements. What is the shape, right? So for 3-dimension data, it is going to be depth x rows into columns, right? So depth means what? How many matrices are repeated one behind the other? And the ndim is nothing but our what? Basically the dimension of this particular array, right? So this is nothing but our 3-dimension array. We all know this. There are totally 12 number of elements. This calculation is based upon what? So this is how many matrices are repeated one behind the other. Let's say over there are 1 million matrices. Okay, or else I'll just add one. Okay, so something like this, right? So there are 4 matrices repeated one behind the other. So that how many matrices are repeated one behind the other? Each matrix contains how many number of rows, and each matrix contains how many number of columns over here. Clear? That is how you can find out the insights of an array over here. Clear, everyone? Once more. Okay, so pretty simple. There are three attributes: size, shape, and ending. Size will give you the total number of elements. Total number of elements, how do we calculate it, right? So let's say, take this as an example, small array. 1, 2, 3, 4, 5, 6. There are 6 elements. This will give you the total number of elements. For shape of the matrix is basically what? How do we calculate? Rows into columns. For 2 dimensions, same thing over here as well. That is rows, comma, columns. Only the changes in 3 dimensions it will change. That will change as how many matrices, that is depth, right? So depth, comma, rows, comma, columns. Each so basically there are 4 matrices repeated one behind the other. So 1, 2, 3, and 4. 4 matrices repeated one behind the other. Each matrix contains how many rows? Each matrix contains 3 rows. 1, 2, and 3. Right, and each matrix contains how many columns? That is 2 columns, right? Notice 1 and 2, right? So that is what your output which you are able to see. And endim is a function that will help you to find out what is the dimension of your array. Okay, one thing, guys, do not, endim, yes, you can find out, but there is an easy method for you to find out what dimension array it is actually. How can you easily find out? Is basically simple. Just count the number of brackets either in the beginning or at the end, anywhere, right? So either in the beginning or at the end, right? So you will be able to literally find out what dimension data it is. Notice there are 2 brackets, it is 2 dimension data. If there are 3 brackets, this is 3 dimension. Similarly, let's say if I had 4 brackets, it is 4 dimension data, right? So easily you can find out by looking at it itself over there. Need not, you have a attribute, but again, by looking at it in a glance as well, you can tell it. Okay, so what dimension array it is actually over there. Okay, now wait, before I proceed, one second, I want to show you guys something. Ignore this code, do not write down, we'll come to this one. Image rs, I'll just import one data. One second, I want to show you guys something. Okay, so to data dot anything, I'll just take this one. Okay, first thing, we have this particular matrix. If I'll run this particular code, you have an array over here. First question number 1. What dimension matrix is this right now?
3.
How can you tell?
3 braces.
Yes, just count the number of brackets. 1, 2, and 3, right? So there are 3 brackets, either in the beginning or at the end. You'll literally be able to find out what dimension data it is. Okay, so im dot, let's say over here, size. Okay, so size. I'll run this code. What is this number give? What is the meaning of this number?
Total elements.
Total number of elements inside the data. Okay, so im dot shape. So what this 512, 512, and 3?
Length, breadth, height.
Yeah, dimension, row, column, whatever. Yeah.
How many matrices are repeated one behind the other?
Quite well.
512. Okay, each matrix contain how many rows?
512 rows.
Quite well rows.
512 rows, and each matrix contains how many columns? That is
3 columns.
3 columns. Okay.
3 columns.
Now, I want to make you guys one. Of course, the endim which you are talking about, dot endim. It is. We all know that it is nothing but a 3-dimension data because we have counted the number of brackets over here as well. Pretty simple. You can look at it and you can tell that. Okay. The other functions basically help you to find out the other insights of an array. Okay. Now, one thing. For mathematical operations, maximum you will be dealing with, most of the time, literally you will be dealing with our 2-dimension data itself. Do not get worried about 3-dimension data much, right? So don't get worried. It's pretty simple. So yes, it might look a little complicated, right? So, but again, while processing the data, see, 2-dimension data is what? Basically your Excel data, your CSV data, etc. Right? But what exactly is 3-dimension data in a real-time scenario, right? So what are these numbers over there? What does this represent over there, right? So 3-dimension data are basically what? Your images, your audio files, etc. Right? So if you have a binary file, you convert that into this one. Those type of data is what something called as 3-dimension data over here. Yes, the numbers which you are able to see, there are methods where you can actually do what? So clearly.im, you can squeeze the 3-dimension data and look at it. So the numbers which you are able to see in the back end, this is the data over there. For each pixel value, what is the RGB value for that one? So that is the values, that is the numbers which you are able to see actually over there. But in the back end, this is the image over here. So don't worry that, okay, what is this 3-dimension data? Most of the time, you might be only processing only 2-dimension data. 3-dimension data is rare projects which we actually deal with, but do not get worried over there, guys. Okay, clear? I'll delete this. We'll come to 3-dimension data in depth later on, huh? Okay, any other questions?
Hi, I have a question. So, in case of 3-dimensional, so the shape, the shape of the matrix, no matter the depth, the shape of the matrix should always match each number of
Okay, I understood your question. Okay, Chef. So basically, so something like this, and let's say over here, this particular array has, let's say, for example, only one column, correct? So now the question is, if I were to try to run this code, it will fail. It will not. Yes. To answer your question,
so
the
the
answer is yes.
Okay, so the each matrix should be
Should be of the same shape exactly over there.
Same shape. Okay.
Yep. Okay. Now, is this the only method of creating an array? So what we did until now is basically we created an array manually over there, right? So is this the only method? No, there are a couple of other methods. Now let me quickly increase my page, right? So there are other methods as well. Okay, so depends on what scenario, what you are actually working on. Okay, so here first method, right? So simple, that is, let's say zeros and your zeros like. Okay, so we have a simple function that is zeros and zeros like, that will help you to create an array. But the thing is over here is all the elements inside your array are going to be filled with zeros. Similarly, we have other functions, right? So let me go step by step. Let's say if I want to create an array, basically initialize an array and fill the elements with 0. Okay, so if you try to relate it to a real-time scenario, it is something like this. You have 2 columns. Your task is to do what? Add these 2 columns and store the results over there. Okay, so but the thing is, you have to initialize this particular column, correct? So you need to at least put it as a dummy value or something like that, right? So to initialize an array, we use this type of functions over there, right? So zeros, and let's say basically you are initially creating this particular column with filled with zeros, or let's say ones or something like that, right? Now how do we create it? So np dot zeros is a function that you can actually use. But if you press one thing, try not to by heart anything. If you literally sit down to by heart things over there, right? So how many things which any human being, let's say for example, even me, how many things can I remember, right? There are many functions over there. See, literally there are many functions, and many of them are actually modules. Inside them, there are another couple of functions, right? So do not sit and by heart. How do you remember? How do you find out what this function does? Is bring the cursor inside that round bracket. Press Shift and Tab. Try to develop a habit of reading the docstring. Okay, because it is not possible for anyone to by heart all of these functions, right? So not at all required, right? So try to read the docstrings and understand it. What parameters does it take? It takes something called a shape. Okay, then by default there is something called as data type as float. We'll come to that one. Okay, now what exactly is shape, right? So if you see, shapes are basically passed in a form of a tuple, right? So you need to provide a tuple over there. Let's say if I want to create an array of, let's say 2 cross 5, 2 rows and 5 columns, you'll be able to create it. No, if I want to create an array of, let's say 10 cross something like that, right? So yes, you will be easily able to create an array. But the data over here will always be what? So basically you can create an array of not just this, you can create an array of any dimension, that like this, right? So 3-dimension, 4-dimension, 5-dimension, until 10-dimension also you can go, right? You can create an array of any dimension. By default, the elements filled will be what? Basically it will be filled with nothing but our zeros over there, but the data type for the zeros is going to be what? Float. If you want, no, I want an integer value for that, right? Because I want dealing with something like this, right? If you want, yes, you can do it, right? So data type instead of passing it as float, you change it to whatever data type. Let's say over here int, I want an integer data type. You'll be able to generate it over here. Clear? Okay. Now let's say no, I don't want to pass this particular shape manually from my side. I already have an array. So let's say over here I have an array of this one, right? So whatever shape. Okay, I'll just take 2-dimension data. I already have an array, something like this. I want to create a replica of this particular array by filling the elements with 0. So basically, I already have an array, but I want to create a replica of this particular array, right? So that time, what you can go ahead and you can use is zeros like as a function, right? So in this case, you need not provide the shape at all. You just provide an array which you want to copy the shape. It will copy the particular shape of an existing array. Zeros like is for duplicating or replicating. But if you are creating it from your side, you can or use something called as zeros over here. Clear? Okay. Now, similar to this, opposite of this, right? So we have zeros. We have opposite of this ones and ones like. Okay, so same concept, but only change over here is if I am trying to create an array from my side, ones, and let's say over here shape, I'll provide it as let's say 2 × 3 for an example, right? So it will create you an array. No, let's say I already have an array. So let's say in this case of any shape. If I want to copy the shape of an existing array, np dot once you can go ahead and once like you can go ahead and you can use and you can pass the existing array. It will copy the shape of an existing array over there. That is once and once like, guys. Okay. Now similar to this, zeros is done, once is done. There is something mix of both that is referred as something called as identity matrix. Any idea what exactly is identity? There are two scenarios that has to match for an identity matrix.
Maybe the elements of both the matrices are same.
Exactly. So it should be something called as your square matrix. Okay, so the total number of rows should be equal to what? Total number of columns. Okay, so total number of your columns. Okay, so number of rows should be equal to total number of columns. Okay, so identity matrix will always going to be a square matrix. Second rule is the diagonal elements are nothing but our diagonal elements are zeros or 1. That is 1, and rest all. Okay, and rest all the elements are zeros over there, guys. Okay, so pretty simple. Identity matrix. If I want to create an identity matrix, how do we do it? It's np dot identity as a direct function over here. And now, see, anyhow, it is going to be a square matrix. So what these people have done is it is not. So these people are basically collecting n over there. Why n? Because it is a square matrix. Basically, you just pass a single value. Let's say over here 5 or let's say whatever it is, right? So now it will do what? Basically, it will create a 5 cross 4 matrix or whatever shape which you have passed over here, filling the elements as what? Diagonal elements are going to be 1 and rest all the other values are going to be zeros over here. Okay, so the D type option is present in every places, but again, so this is how identity matrix you can go ahead and you can create it. Okay, now let's say no, I don't want to create an identity matrix. Okay, so I want to generate numbers like how we have in case of our range function. Remember, let's say over here range of, let's say something like this. Okay, first question, range of 10. What will it do? Will it create the elements with zeros or let's say ones or let's say identity, whatever it is?
0 to 9.
Sorry. So basically, it will create the values within that particular range. By default, the start value is going to be 0, and the stop value is whatever which I'm providing, and the stop value is exclusive, right? Now, let's say something like this I want to create. I don't want to create a matrix with zeros or ones or identity. I want to generate numbers values like this. How can I do it? Is there a function in case of our NumPy? Yes, the answer is yes, it is actually available. Which function can we actually use? We have a function, something called as arange as a function. Okay, so arange, right? So how do we use it? Okay, or what are the parameters which we use in case of arange? Arange is similar to our core Python range function, almost same. By default, see, range of 10, if I pass, there are three things, right? So let's say over here, there are three things. That is your start value, the stop value, and there is something called as a step as well, right? So these are the three things which you can provide in case of range function I'm talking about. So start by default, if I do not provide it, basically what? It is going to start with 0. Stop whatever the user provides, right? So the user input over there, right? Then again, by default, what is the step? Step is 2, 3, 4.
1.
Step is 1. So now if I run this code out, right? So let's say over here, if I am telling, hey, start from 5. 1 second, let me just use the print statements. Okay, so see over here, this is the data, right? So now let's say, no, if I am telling, hey, something like this 5, 10. Now what will be the output if I execute it?
5 to 9.
One question, why is it not 4 to 9? Because see here it is reducing one element, right? So here 4 to 9, will it be?
5 to 9.
Yeah, 5 to 9, right? Because the start is inclusive and the value of your stop is exclusive, means it will stop one value before that, right? Okay, now same thing, let's say if I am trying to provide, let's say over here, comma 2, what will be the outputs over here?
5, 7, 9.
5, 7, 9. Basically, you're jumping two values ahead of this 5, then again 7, then again 9, right? So basically, you're jumping two values ahead of it. So this is our core Python range function. Same thing you can also achieve by np.arange. np.arange. So let's say over here 10. So 0 to 9, but it will directly generate you an array, right? So notice 0 to 9. Let's say if I'm providing, let's say 5 to 9, that is going to be generating values what? 5 to 10, basically 5 to 9. The start is inclusive, the value of your stop is exclusive over there, right? Now again, let's say if I want, I can also provide something called a step as well. That is comma, let's say 2. Same output, same things you will be able to achieve over here as well. But what is the advantage? How can you expect me to use your function when I have a core Python function as well? What is an advantage? Do you provide anything new over there? The answer is yes, it actually provides. For an example, can I take from 5.5 and go until 10.5? Is this allowed?
No.
It is not at all allowed. You can only pass an integer value over here, correct? In case of our Python function, you can only provide integer values. But this limitation you can overcome in case of our NumPy. Here you can even provide float values as well. Let's say 5.5 until 10.5, something like this, right? Notice you have an output. Similarly, no, I don't want to take the step as 1, 1. Can I take step as let's say 0.5 or 0.25, whatever it is, right? The answer is yes. Here you can play around with it. Clear the advantage of using arange function? One more thing. Arange function also plays around with a nothing but our date ranges as well, guys. Okay, I'll just give an example. Let's say if I want to, but I don't remember the exact syntax of the date format, but let me try. It also allows you to pass date ranges 2025 hyphen, let's say 01 hyphen 01. Let's say this, I'll just take this as 30. I'm just trying it out with this date range. Will it work or not? And the data type for this one is equal to dir of np. There is one data type of something called as date time, something like this. Date time 64. Okay, so not just the range of integer or float values, you can also take the range of your date values as well. Like how I have taken the complete month's date, right? So like this, you can take the date ranges as well. Okay, so okay. Hey, sorry, was I going too fast?
To an extent, yes, if that's not
Sorry, guys. Okay.
Otherwise,
Okay, so really sorry because actually I just went ahead because the syntaxes are actually there's no change in the syntax. Same thing, we are just providing a different values. But again, I've reduced my speed. Really sorry for that. Okay.
kind of you. Thank you.
Yep. Okay. Now like this you can create a date ranges. Okay. So but you can even so if this means that you can also create date ranges of with the step as well. It's alternate days, alternate 3 days like this, right? So you can actually create it. But I will give you one syntax. I want you guys to work on one task. This is which month? That is 11th, right? So wait. First thing is I will put the dates. This is which month? That is 11. 01. I'll take 11. 11 and okay. So we have the wait. I'll take until December 1st because the stop value is exclusive now. So 01. Okay. So you have the dates. Okay. So now I want you guys to help me out to do something. In these dates, help me to find out the dates of Sundays. Just the Sundays I want. Can you guys give me the code to get this out? I'll share this in the chat box. Date of I want the Sunday's dates. One second, I'll take. How you do it? It's your wish. So November Sundays are basically two. We have 2, 9, 16, 23, 30. These are the values which I want in my output. The hint is you can even deal with step also. That is the hint. Exactly. So yes, I see many people have developed this logic. Very simple. Start with this value. Jump 7 dates ahead of this, right? So you'll by default get the Sundays over there. So right. So yeah, you can write down a loop. You can use like time libraries and calculate. But again, in this case, you can easily do it with this over here, right? So but start with what? One of the Sunday, that is 02 over there. Run this code out. You have the dates of all the Sundays present inside our data. Clear, everyone? Arrange function. Okay. So what all functions? Just a quick recap.
I have a question. I'm sorry.
Mhm.
In the dates function, right? Do we have a function to identify date of each date mentioned in the array?
Date of each mean
Day of
no,
each
day
date.
of each. No, here you do not have it, but you can do it with in case of our time libraries. You can even use import time or date time library also. But here in NumPy you don't have it directly.
Okay, okay. This is like pretty static. So okay.
Yeah, because yeah, that's what I just wanted to have an idea about this step. But again,
Okay.
yeah, this is static.
Sure, sure.
Okay. Now, just quick recap. What are functions? See, simple guys. Array. Array is a function for us to manually create. Then we went through zeros and zeros like. The difference over here is if you want to create manually 0, if you already have an array, 0 is like to copy the shapes. Then again ones and ones like to if you want to create manually, if you already have an array, ones like. Then identity matrix, right? So diagonal as 1, rest all are zeros. Then series of numbers, that is a range function. That is a range function to generate this particular data. But there's a limitation. A range function will always produce one dimension data. It will never produce two dimension data. Then you have to change the shape. Okay. Okay. What if we wanted to start from October 1st? Yes, you can, but here you have to do it manually itself, Sachin. If that is the scenario, no, then use this library. So see here, you can play around. So if you want to strip the time, you can easily generate from here time.strf. So if you press shift and tab, no, see here you have all of this options over there. AM, PM also you can generate, date and time. You can extract the years from the dates, months from the dates, etc. Whatever you want, you can play around. But here NumPy, just an idea. I just gave that's it. Okay. Now series of numbers also we generated. But what if I don't want that? What if I want the values to be random over there? I don't want continuous values. I don't want zeros. I don't want ones. I don't want identity as well. What if I want to have random values inside my array? What can I do in that type of scenario? So yes, we have a function directly available that is random as a function. Okay, here there are a couple of things. I'll try to take you guys through them. Okay, so but this is not a function. Random is actually a module inside NumPy. Okay, so there is directly a random module as well. You can use this one as well, but again, it is a module inside NumPy. Okay, so if I want to generate some random values, okay, so let's say over here ARR is equals to np dot random as a function dot. Okay, so I'm getting one more step inside this because this is a module. This is not a direct function. Dot, let's say ran. I'll just press tab. There are a couple of functions like this. The randint is the functions which we usually use, right? So rand, let me take an example. Press shift and tab. What does it accept? What are the parameters which I need to provide? D0, D1, D until the end, right? So random values in the given shape, right? So whatever values which you are providing, that is going to be the shape. So I say 2 cross 3 matrix, right? Now it will do what? But there is a thing. The thing is, rand as a function will always generate random numbers within the range of 0 to 1 itself. Okay, so 0 to 1 itself, right? So here, if I run this code out, it will create a matrix of your desired shape. So I can even go until 3 dimension, 4 dimension, whatever it is, right? You can create a matrix of your desired shape. You just need to provide the shape of the matrix. But the random values which it will generate will always be within the range of 0 to 1. Notice there is no value less than that. There is no value more than that at all. Always within this particular range itself. Okay, but there is similar function to this, that is rand n as a function. Okay, I'll just reduce this one. Okay, rand n. So if you press tab now, see here you have rand n as a function. Now if I run this code out, you guys tell me, is there a same limit of 0 to 1 in this rand n function? No. Will it only generate positive numbers? No. It can generate negative numbers. It can even generate positive numbers. But there should be some logic where the numbers are generated, correct? So if you press shift and tab, see they have explained you this one. Random samples from basically standard normally distribution, right? So normally distributed data. So this you'll learn in your statistics classes, but again, I'll give you one hint. There is something called as right skewed data. There is something called as left skewed data. There is something called as normally distributed data, something like this, right? So normally distributed data. So this rand n function, if you plot this particular data into a graph, it will be always be a normally distributed data itself. Based upon that logic, it is generating random value. The above function is within the range of 0 to 1, but the below function is normally distributed data over here. You can have positive values, you can have negative values within any particular range. Clear?
Can you scroll a little up, please? The first one there. Okay, thank you.
Done. Okay. Now, no, I don't want to generate within 0 to 1. I don't want normally distributed data. I
One
want.
second. I just have one question here.
Hmm.
In the first example, when you gave 6, 2, 3, so what is the importance of 2, 3 there? 6 means it is 6 digits after 0. I can see 0 point and 6 digit. But what
Wrong,
is the
wrong.
importance of 2, 3?
Now, this is the shape of the matrix which I'm providing. 6 matrices repeated one behind the other. 6, 1, 2, 3, 4, 5, 6. And each matrix contains 2 rows. Each matrix contains how many columns? 3 columns. That is the shape of the
Oh,
matrix.
that's okay. 60 means 6 digits and 2
Yes,
rows,
no,
3 columns.
not 6 digits. Depth
Then,
is 6. So let's say over here, in 3-dimensional data, let's say over here something like this, right? One matrix
yeah,
repeated.
sorry, I missed the initial part of the class, so maybe it's very
Oh,
basic question.
okay. So depth is 6. There are 6 matrices repeated one behind the other. Okay, and each matrix contains 2 rows, and each matrix contains 3 columns.
Yeah, but I didn't understand. 6 depth means what?
Okay, so I think you might have missed this part, but again, so for 3-dimension data, right? There are, where is it? Okay, so see, we have 3-dimension data, correct? So we have in 3-dimension data, that is the 3 axes: depth, rows,
Okay.
and then columns.
Depth.
But in 2-dimension matrix, we have
Rows and column.
rows and columns, right? So let's say over
Correct.
here, in this case, there is a matrix. Imagine it this manner: 1, 2, 3, 4, 5, 6, 7, 8. So imagine it, there are totally 8. So how many rows over there? 1, 2, 3, 4. 4 rows. And how many columns in this matrix?
2.
There is going to be 2 columns. Okay. Now imagine the same thing. Instead of having a 2-dimension, this is 2-dimension data, correct? Instead of having this, you have 3-dimension data. So you have, let's say, one more matrix, a type of a cuboid. Imagine a cuboid. So in a cuboid, you will have this one, right? So something like this. Imagine a cuboid, right? So this is one matrix, and the other one is a behind one. Okay, so in the cuboid, now same set of elements, right? So now the question is, how many matrices are repeated one behind the other? There are two matrices. One is this one, and the second one is this one, correct? So this is going to be the depth. This is going to be the depth. Let's say there are 3 matrices. Then the depth is going to be what? The depth is going to be 3. There are 4 matrices. The depth is going to be 4, right? So X, Y, Z. So in that case, in this scenario, what we saw in the below hand side is basically what? There are 6 matrices repeated one behind the other. One matrix, second, third, fourth, fifth, and sixth. There are 6 matrices one behind the other. Each matrix contains 2 rows. Each matrix contains how many columns? 3 columns.
3 columns. Okay, so there are 6 entries. Okay, got it. Yeah, thank you.
Okay. Now, so rand n function and rand function. Clear, everyone? What is it going to produce? See, inputs are same. So 2 cross 3 inputs are same. There is no change in the inputs, but only the output what I'm concerned about. The output over here is in the above function. Always the numbers are the random values which it is going to generate is within the range of 0 to 1. But here there's no such limit. But yeah, the logic for it to generate over here is it is always a normally distributed data over there. So there's no skewness in this case, but in this case you have the skewness, Sachin. Okay, now I don't want within this range. I want random integer values, some 10, 13, 20, whatever XYZ. Is it possible for me to produce that? The answer is yes, it is actually possible. How? In the same function, okay, let me take this one and pitch it over here. Okay, so in the same function, you have one more thing, something called as rand int. Okay, rand int as a function. So press shift and tab, read this: low, high, size, etc. We have this one, right? Now low, by default, the none, high is none. There's no limit, infinite, right? So there's no limit. Okay, so now let's say if I'm providing 10 over here by chance. Okay, so see, I'll run this values over, keep on running this one. It will always generate a random value from 0 to basically what 0 is inclusive. From 0 to 10, start is inclusive. If you see, if you read the docstring, low value is inclusive and the high value is exclusive. Okay, so if I give, let's say 5 comma 10, I have a simple question. In at least one of the random values, will you have 5 as an output? Yes or no?
Yes, it is inclusive.
No.
It is inclusive. It is inclusive. In one of the scenario, at least if one see one value I got it, right? But in even if I run this 1 million times or 1 trillion times, will I have 10 in my output? Yes or no?
No.
The answer is no. It is exclusive. Actually, this is actually used in a game. Wait, which game is this? When I want you guys to recognize this game. 1 second. That is start from 1 and go up to 7. If I run this code out, you have this. This is used in a game. This was pretty famous in lockdown period. Which game is this?
Ludo.
Exactly, Ludo. Remember, we might have played. There's a dice over there.
Dice
It
one.
will yeah, exactly, right? So see, this is the logic. It will generate random values from 1 to 7. 1 is inclusive, 7 is exclusive. Means it will stop one value before that over there. Okay. But my question was different. Now I wanted to generate random numbers within some range, but I wanted an array over there. I don't want a single value as an output. How can I generate an array? So press Shift and Tab. Read this. There is something called a size. Also, you can provide. What you can do, then you can give a size over here is. I know it should be shape, but again, it is size is what they have kept, guys. Okay, so people create with different names, right? So 2 cross 4 matrix, 2 rows and 4 columns. If I want, you can create. See, 2 rows, 4 columns with random numbers within this particular range. If I want random values, or let's say 3-dimension data, can I give, let's say 3 matrices repeated one behind the other? The answer is yes. Right? It will generate random values of your desired shape matrix within this particular range. Clear? Rand int function.
Sorry, that 1,7 is what?
Low value and the high value. From where to where your random integer value just needs to be generated, and the shape of the matrix.
No, sir, still not clear. 1 and 7.
Okay. So wait. Okay, simple scenario. I have a question. I want to create. My target is what? I want to create random values from 10 to, let's say, 15. 10 to 15. If I run million times, you have to keep on generating me a random integer value within this particular range. Okay. So what will you give? That is where you'll be giving 10 over here, the low. From where to where? But the problem is, this is inclusive, this is exclusive. Means what? It will stop one value before that. So that's why if I
Okay,
want
so
to
it will be 10 to 15 then.
exactly, it's 10 to
Yeah,
15.
okay,
From what
got it.
range to what range? Okay. Any other questions? Rand int function, rand or random.
Actually, I just want to know what are the use cases of creating this kind of matrices like random identity or matrices containing 0 and 1 elements only.
Okay, simple scenario. All of these matrices are simple, used for mathematical operations, right? So imagine one column I have, let's say np dot array. Okay, so I'll just take np dot array. Okay, so 1, 2, 3, 4, 5. Okay, so I'll just take small set of numbers so that I can explain this. Okay, so let's say something like this. I'll take, let's say this is B, and let's say, yeah, let it be same number of elements. Okay, my task is to do what? My task, imagine this is column A, column B. Okay, I want to perform addition element to element. So this to this one, 1 plus 1, 2, I want to store it into the third column. 2 plus 2, 4, I want to store it over here. 3 plus 3, right? So basically all this addition over here, element to element, I want to perform. So how do I proceed, right? So simple scenario, right? So how do I proceed over there? So for us to proceed, so what I will do is I will initialize a third column. Basically, I will create a dummy column by filling the elements with 1 or let's say 0. So how do I initialize, or how can I replicate an of an existing matrix? C is equals to what? np dot zeros, right? So zeros. Okay, so sorry, 0 like, because I already have an array. Okay, I did what? So I created a dummy column filled with what? Zeros over there. Now my target is to do what? NP dot add A comma B and store the results in C. So if I run this code out, the values of that will be stored over here. Understood now? Okay, see, go step by step. I had two columns. I created a column, dummy column filled with zeros. Then I performed the addition of these two arrays and dumped the results into third array. That's it. So simple words, right? All of the use cases over here is to perform mathematical operations. Mathematical operations, anything you can take. In simple example, addition itself you can take. Okay. Now let me try to proceed.
So NumPy will be used only when your table has just integer or any numerical values, right?
Yeah, basically for mathematical operations, most of the time we deal with numerical values itself. But yeah, sometimes what happens is, let's say over here, the data also which we receive, right? For an example, let's say an string column. If I capture this into a single row or column, that will by default be a NumPy array. That can also be one of the scenario.
But
Okay, but
yeah.
But for operations, right, most of the time we use this itself, that is your numerical data itself.
So say for example, I have a table which is combination of multiple data types, string and all that. But if I have to perform NumPy this thing, then I need to put all these numerical values into a separate table and then do calculation of
separate. No. If you capture one column or one array, one column or one row, right? So that will by default be a NumPy array.
Okay. But say for example, I have a table where I have 15, 20 columns. In that 20 columns, like I have just 4 are integer or any numerical value. Others are like maybe string or name.
So in that case, so for an example, let's say over here we have 4 columns. One is int, string, float, bool, right? So if I capture this particular column, this will be a NumPy array. So by default, what will be the data type for this? Int. So it's string, right? So if I capture this particular column, it will be a string column because one column itself I'm capturing. But if you are capturing a row level data, that is where we'll face this issue. Because one is integer, one is string, one is float, one is bool, right? Then everything will tend to become string data type. That is a problem. That is a problem over here in NumPy. That's why NumPy only for column to column addition or subtraction or whatever it is we perform, but for handling the data, pandas has various other options for that.
So for NumPy, we need to just go at the column level only.
Exactly. Okay. Now,
have you imported any package for this? Because I missed the start of
have
session.
we imported any package? Yes, no? So import NumPy as NP.
Okay, thanks.
Okay. Now
I have one question here. You're generating array that, go at the end.
Go ahead.
Actually, only one number is printing. So array is just variable you're using, right? ARR?
This is just a
on
variable.
line number 108, yeah.
This is just a variable.
Yeah.
But here it is, I can give any name, let's say A also here.
Yeah, correct.
But
So it's not
rand
actually
int, this is not an array. This is rand int will generate by default an integer value. If you want an array, use the parameter size.
Oh, the same function, just parameters. Okay, different parameter. Okay.
Yeah.
Okay. Thank you.
Now,
one more question. What about memory allocation in Python? Does it contain continuous memory allocation?
It actually contains similar. Okay, it is similar to C. 1 second, I'll just. But shall I come to this at the end, Arunima?
Yeah, sure.
Sure.
Okay.
Okay. Now until now, what did we see? We saw different methods of creating arrays, right? So we saw manually how to create it, filling with zeros how to create it, filling with ones how to create it, random values how to create it, right? So all of these different methods which we saw right now until now. Now, what if I want to, let's say for example, I already have an array. The question over here is, can I change the shape of an existing array? Is it allowed? Yes or no? If yes, how do we do it? Correct. So how do we change the shape of an array over there? How do we change the dimension of the arrays over there? So the same concept in our big data also is what we use a lot. Okay. So yes, we can do it. There is something called as reshape as a function which we can actually use. Reshape how, right? So what is the syntax? How do we do it? It's pretty simple. I'll just take one. I'll do two things. First, I'll take one dimension. Then I'll go for 2 dimension and 3 dimension, right? So reshape, how do we do it? Let's say I have a simple array. Let's say ARR is equals to NP dot arange. Let's say over here, I'll just take 10 elements, okay, and something like this. Okay, so let's say I have an array. Array contains how many elements? That is, there are totally 10 elements, starting from 0 to 9. Okay, so first question is, always I'll take 12 elements. 12 elements, so that it's easy for me to convert. Okay, now totally there are how many elements inside this particular array? We all know that there are, if I do size, there will be totally 12 elements inside this particular array now, right? Now the question is, can I change the shape of this particular array? The answer is yes. How? So we have a simple function, that is arr dot reshape to use. Okay, so reshape to use, basically how or what are the parameters which I can provide. Okay, if I press shift and tab, there is a simple parameter. Order, I'll come to this later on, right? So if you see, order is present in all the functions. Okay, we have something called a shape. Okay, so you need to provide the shape. Okay, so basically means what? You can change this particular array to whatever shape of your own choice. But there is a rule. The rule is basically what? If you multiply the sides of an array, it should always be equal to the total number of elements. Means what? Can I change this array to, let's say, 2 cross 4? The answer is yes or no, right?
No.
So simple. 4 to the is what? 4 to the is 8. So total number of elements, is it matching? The answer is no. It will throw an error. Okay, but the same thing. Can I take, let's say, for an example, over here 3, right? So is this allowed? 4 3 is what?
Yes.
12, right? So now the answer is yes. This you can take change this particular shape. So 4 cross 3, 3 cross 4, whatever you want, right? But the only rule over here is you can reshape an array of whatever shape of your own choice. The only rule is if you multiply the sides, it should be always equals to the total number of elements. So in that case, 1 second. Can I'll do it in a different cell once. Can I reshape this particular matrix to this over there? Yes or no? The answer is yes. 2 2s of 4, and again this into this, right? So again we are coming back to the total number of elements, right? So again, can I reshape this to, let's say, 6 comma something like this, 6 comma 2, 6 comma 2? Is this allowed? The answer is yes, it is allowed, right? So again, the same matrix, can I reshape this into, let's say, over here 2 cross 3? Is this allowed? The answer is yes, it is allowed. As long as if you multiply the sides of an array, if it is equals to the total number of elements, you can easily reshape this to anything over here. Clear up to this point?
Why do we reshape?
Why do we reshape? Let's say, for example, here I have an okay, so where is that example of addition? One matrix is of another shape and the other matrix is of a different shape. If I want to perform the addition, will it be allowed directly? No.
No.
Different shapes, it will not be allowed. So if I want to reshape, yes, you have an option.
Okay.
Okay, so now wait. Now there is one helping hand. The helping hand for you guys to is what? Basically, you can use something called as infer in case of reshape. Okay, there is one parameter where you can play around with infer. Infer means what? Okay, so infer means basically what? Let us try to understand that, right? Now imagine it in this manner. Now imagine there are 1 million rows over there. Okay, so the data is very huge, right? Now it is a little difficult for me to, imagine. See, here I have only 12 elements. Changing the shape is very simple, right? So I don't. Okay, so I want to do something like this. I want only 2 rows. Yeah, total number of columns. I want. Let's say there are many values, right? So it is not possible for me to directly perform the calculation. What you can do is you can use any negative number over here. Okay, so let's say over here something like this. This -1 means what? It is just like you're putting the value of your x over there. So totally, there are totally how many elements? That is 2 into x should be equals to 12, correct? So basically, in place of x, I am just putting what? -1. This will help you to play around with huge data, right? So basically, what it will do, depending on the total number of data, it will fix you 2 rows, and the number of columns you are allowing your NumPy to decide. So you can use infer in any location. See over here, for an example, hey, number of columns you decide, but I want only 3 columns, right? Will it be doing? Is it possible for me to do it? The answer is yes. But only one rule is this number should be a multiple of your 12. So basically, you should be able to divide 12 easily without a float value. And if that condition satisfies, you'll be able to, if you want, you can use infer if you have huge data. Clear up to this point?
No. Can you please repeat? Because I didn't understand how the negative number works.
Okay. Now let me repeat it, right? So pretty simple. Okay. So for an example, I have an array. Imagine I'm not pointing huge data, but I'm just taking some sample data over there. Okay. So something like this, right? I have a huge data over there. I want my NumPy, I want my Python to tell that, hey, I want only 4 columns. I want 4 columns compulsorily, but the number of rows, I want my Python to decide what will be the total number of rows. Because the data is huge, I'm not able to calculate. Okay, so yes, here it is simple, but again, just imagine it in that scenario, right? So that's where dot reshape. Okay, so I want what? I want total number of rows to be decided by my NumPy, but I want only 4 columns inside me. I'm fixing this 4 columns, but the total number of rows I'm allowing my Python to decide, right? So you can use something called as negative value. That is infer, which we refer it as. Infer for rows or columns, anything you can use. So something like this. Okay, I'll give another example, right? So here I want, hey, I want 2 rows, or let's say I want 6 rows to be fixed. But you decide what will be the total number of columns. That's where I can use -1. Okay, I want, let's say over here, 6 columns to be fixed, but decide what will be the total number of rows. You can use infer in any of this particular location. Clear?
So from where is the 12 number coming?
Where is the 12 number of? Okay, so here, this is the array, na? So see, the array which we created, where is it? This is the array, right?
So you first define the range and then you reshape it like that.
So this is the array which I created. So np.arange 0 to 12, right? So this
12.
particular array, how many elements are present? Dot size. There are totally 12 elements. Count it, na? So see, 0, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 12, right? So there are total elements of 12.
Okay.
So,
and then you reshape it in the rows and columns you want.
That you can reshape it, but rule over here is what? Multiply the sides. It should be equal to the total number of elements. If the data is huge, yeah, you can use infer. Infer is basically what? You are fixing something, allowing the other thing to be decided by our Python over there. Clear?
Yeah, thank you.
How does we take -1 and -1?
Sorry?
A -1, -1. Can you take?
Oh, that you cannot give. You can only give one unknown shape. Okay, so for an example, see, 2 into x is equals to 12. This you can calculate, but you can find out the value of x, correct? But let's say over here, x into y is equals to 12. Now this is not possible for us to calculate directly, right? So that will not be allowed. So even if I try to give it, it will throw you an error telling that you cannot give 2 unknown dimensions. You can only provide one unknown dimension.
So you can say -1 is in the syntax.
Sorry?
-1 is in the syntax, you can say.
-1?
Means -1 is fixed to get these kinds of multiples by the system itself.
Sorry,
no.
I did not.
She's saying
I mean,
to use -1 or can you use any other negative number?
Okay.
Function definition.
You can actually take anything. Any negative number is in infer itself. You can take anything.
Okay.
You can take anything. But negative means infer. Okay. Now, here I actually did what? I showed you guys to basically convert a single dimension data into multi-dimension data, correct? So basically, if you see over here, single dimension data, we are converting it into multi-dimension data. That is what we are trying to perform. What about the opposite manner? Multi-dimension data into a single dimension data. Is it allowed? The answer is yeah, it is actually allowed. How can we achieve this task? This task can be achieved by, there are actually, initially we had only Ravel, but then they came up with Flatten as well. But any of these functions you can actually use over here, guys. Okay, so I'll show you what does it mean, right? So let's say I'll take this dot reshape this to, let's say over here 2 plus minus 1. Okay, so I'll take, let's say, okay, imagine this is the array which we have. That is of what shape? We have 4 rows and how many columns? 3 columns. Okay, now I have a task. Okay, so we have what dimension data it is. Okay, I'm just giving an example of 2-dimension data. You can actually flatten nth dimension data, guys. Okay, so a simple question for all of you guys. I'll start a loop over this. So 1 second, I'll start a loop over this for I in, let's say, this array, and if I'm printing the values of your I, what will I iterate over? Will I iterate over 0, 1, 2, 3, or let's say will I iterate over each row at a time? What do you think I will iterate over in
Row.
this?
It will go row.
For the first iteration, wait, option number 1, is it going to be 0? Or for the first iteration, option number 2, this whole row is going to be present.
Whole
Option
zero.
A or B?
B.
Who all
Zero.
thinks A?
A.
Okay, so wrong. So who all told this one? You guys are wrong. It is actually option B. It is not each item. You'll be iterating over each row at a time. Okay, so you'll be iterating over each row at a time. This is the working of our core Python, right? Now the question is, no, I have a task where I want to do what? I want to basically iterate over element wise. So if you want to iterate over element wise, what do you think? What do you do in this type of scenario?
Through index value.
Nested for loop.
Yeah.
Nested for loop. Right? That is for j in, let's say, I, and then again if I'm printing the value for j, that is how you iterate over, right? So this is for element wise, this is how you do it. But instead of this, what if I give you a simple option? Here, instead of doing like this, you have a simple option that is, this is an array, 2-dimensional array. I agree. ARR dot Ravel or flatten, anything you can use. Okay, so see, Ravel, it is squeezing or converting multi-dimension data into a single dimension data. Or else, if you want, you can also use a newer function that is flatten, right? So anything, right? So you can use any of these 2 functions, converting multi-dimension data into a single dimension data. That is the use of this particular function. One thing here, I want you guys to now focus on the data a little bit. Okay, so little bit just focus on the data. Okay, so okay, now see, this is the output of flatten. What did it do? First row, this is the first row, correct? First row. Then after that second row, it has kept then it has kept the third row, then the fourth row, correct? So that is what it has done. Row major, basically one row after the other, it is squeezing, correct? It is converting it in that manner. I have a opposite scenario. I'll tell you a simple case that, hey, first column I want, then I want the second column, then I want the third column. Then what will you do in this type of scenario? Have you guys heard about something called as transpose?
Transpose. Yes. Correct. Correct. A
Okay.
row will replace by column, right? So that way the normal for will work. Yeah.
Yes. Transpose is basically what? Okay. Transpose is basically converting transpose. Okay. So transpose is basically what? There is nothing but a simple concept of converting rows into columns and columns into rows. So for an example, this is the array. I'll just do what? Dot t. Simple code. See, there's nothing complex at all. Dot t. Right. So if I run this code, what will it do? It will convert rows. Notice, look closely now. This was the row. Now it has become the column. Okay, so rows into columns and columns into rows. Just converting it. That's it. Right. So just to what do we say? Right. So it is just imagine you have a laptop. You are just turning it upside down. That's it. Right. So it is just converting into up and down. That's it over there. Okay, transpose is one of the option. Two, then okay. So once transposed, then if I iterate over, or let's say if I flatten it, one column, then again second column, then third column. This is one of the option which you have. Or else you can do it over here as well. That is what in both of these functions we have this one. By default, the order over here is what order. If you see, if you remember, order we have seen this into multiple functions over there, and many functions we saw whenever we were reading the doctrine. Okay, if you want for column measure, you can do it also. What do I need to do? I just need to change this particular parameter into what? Into F. Run this code out. First column. Notice first column. Then the second column. Then the third column. Directly also you can do it. Or else you can also use transpose as well. Clear?
Um, okay, can you please explain the parameter f, what we're using, and what are the other options we have in that place for order?
There are many other options. I think that is over here we have flatten. A means to flatten in column measure, and again photon con. There are many other options. Um, just take some time and try it out. See, I think C, F, A, K. These are all options which they have. Try it out, but we'll try. Let's see.
I mean,
Let's try. Let's try.
yeah, one second. So now
Mhm.
you flatten it with order f. Like, how is it different from without giving that parameter?
So okay. Step one. See, this is the array. In by default, over here order is what? C, correct? By default, they have stored it as C over there. C means what? First one row. Okay, so notice the row. Then while flattening it, second row, it happened over there. Then again third row. But when I'm doing it like this, first one column. Notice first one column. Then the second column. Are you able to see this one? Second column. Then the third column. Correct. So that is what I'm able to see over here. That is the output. But here, what is it doing? 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. It is continuous, no? So K is also, I think, row major, and A is also available, but I think that is also column major, I believe. Same as C, yeah. So it is same as C over here, but there should be some difference. Just try to look into it. That's it.
All right, thank you.
Okay. Okay. Now,
Excuse me, one more question.
mhm.
So, what is the difference between flatten and variable?
So what happened, right, Mohan? These people initially we used to use Ravel itself. Okay. Then what happened is, see, same order itself parameter we can provide, but it was not clear at all. So what are all options are present over there? They are basically asking you to go open internet and then search for it, right? Then later on, they redeveloped this particular function with a different name using flatten. But over here, these people gave the proper doctrine. That is the only difference. Old and new function. That's it.
Okay, thank you.
In NumPy, you'll be able to see many functions like this, version 1, version 2, but both of them are available still until this date. Because why? Because the versioning of Python, right? If any particular project is working on NumPy 2.1, and they have to change the complete code, right? So that's why they're trying to retain the old functions rather than just deleting and recreating it. Okay. Now let us proceed, guys. Okay. Okay. So before this, can we have a quick break? Yes. Yeah. Then I need a quick break. We'll be back
Can you
by.
go a bit slower if you don't mind, and like give some time to practice?
Yeah, it's getting really too too much.
Okay. Yeah. Sure. Sure.
Speed
Sure.
is really high.
Sure. I'll
First of all,
I'll
it's
go
very
a little.
complicated and it's like too much.
Yeah. Yeah. Basically, it is mathematics as well, right? So the concept is also maths.
Yep.
Okay. Okay. I'll slow it down a little bit more. Okay. 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 Practicing we'll do in some time because not yet, right? So see, I just showed you how to handle the arrays, how to create arrays. Now I'll be jumping into operations, playing around with mathematical operations on the arrays. Okay. We'll practice this, Harshita. Done. Okay, so let us quickly proceed, guys. Hope everybody is back. Am I audible?
Yeah.
Okay. Now, okay, I'll not take much. I'll just small concepts, right? So arithmetical functions and universal functions over there. That's it. Okay. So arithmetic, universal, and over here I'll even try to introduce your statistical functions. Okay, so that's it. Okay, so I'll stop the class after that. Okay, we'll try to at least work on some of the programs, and then we'll again continue back, right? Okay, arithmetical operations and arrays. For this, I'll instead of me showing you guys, I want you guys to first understand the syntax. Okay, so I'll give you guys two lists. Give me a Python code base for this one. So let's say over here, simple list: 1, 2, 3, 4, 5. There are 5 elements inside L1, and similarly L2 also. Let's just create, let's say over here, 6, 7, 8, 9, and 10. Okay, so these are core Python list now. I want to create an so basically simple operation. I don't want to even complicate as well. Okay, so let's say multiplication will take, let's say, or this anything, right? Let's say small, let's say multiplication. Basically, what I want to multiply element to element. So 6 into 1 I want to multiply. So that is 6. So similarly, 7 into 2, 7 to the 14, right? So 14. Similarly, right? Basically, all of this multiplication element to element wise. Can you guys give me a Python code that will perform these operations? Or else more simplified. Let's say addition, right? 6 plus 1, 7 I want. 7 plus 2, 9 I want. So basically, addition of this particular elements, element to element wise. This is the operation which I want. First question, can I achieve it like this? Yes or no? Will it give you the output, desired output?
No.
What will be the output then, Venkat?
No, then we have to go with this NPy, right? Again,
NPy, yeah, it should be in array or like.
No. If I'm forget about NumPy for sometimes. Everybody forget. In core Python, I want to do this part. If I do this one, what will be the output? It will be concatenation, correct? If I run this out, you are concatenating one list upon the other. But this is not the target which I wanted, correct? So I wanted to perform element to element addition. Can you guys give me the code now, quickly?
For loop.
Anything, your wish. For loop,
Map.
use function, map, anything, your wish. But give me the code. In core Python, forget about any library. One, 2, 3, 4, 5. Give me the complete code in Python. Yes, I see different people trying out in different manners. That's correct, right? So either one of this is one of the option, or second option is what? I see from Anit, right? So of course, yeah. So this one, right? So basically what? So you are using map and then performing the addition element to element, right? So awesome, right? So in both of these methods, we are able to achieve this particular task. Okay, now first question. So why can't we do it directly? So this was the simplest syntax, right? Why loop? Why map? Again jumping inside that lambda function, etc. Right? So what is the requirement? What is the requirement? Why can't we do it directly like this? So this will fail, correct? So this will basically what concatenation in case of our core Python. Now the problem is, yes, we can even use a zip or anything, right? So but again, directly we cannot do it. What if there was a method for us to directly perform this operation, right? Don't you think that syntax level also it will become easier? Because not just addition, subtraction, multiplication, anything, any mathematical operation if you want to perform, it will become a little easier for us to perform it. So that's where NumPy gives you an option that, okay, hey, all these operations, you need not struggle with a loop, you need not struggle with map, you need not struggle with anything over there. What if NumPy gives you a direct option? So that's where NumPy comes into picture for playing around with our data. So as I told, right, mathematical operations are pretty easy for us to perform over here. So np dot, let me just convert this into an array, right? So let's say this is an array, and now this is also, instead of a Python list, I'm just converting them into an NumPy array over there, guys. That's it, okay? So this is also an array. So np dot array. Okay, so I have these two NumPy arrays with me. So, but the thing is, here mathematical operations become very simple. Here, if you are giving something like this will not result in concatenation, but in turn it will result in the element to element wise mathematical operation. Like this, not just addition, literally you can even perform any operations as well. So let's say subtraction, let's say over here multiplication, right? So let's say element to element wise multiplication. Let's say if I want to perform division, flow division, all of these operations you can directly perform on our NumPy arrays. It is directly possible. Okay, but be very careful here. What if, let's say, I'm talking about multiplication alone now, guys. Okay, so yes, see, if you look closely, element to element wise, 6 into 1, 2 into 7, that is what it is trying to multiply, right? But if the array is, let's say over here, of 2-dimension data, np dot array. Okay, so here I'll just take 1, 2, 3, 1, 2, and similarly, let's say I'll even take, let's say 3, 4, and I'll just convert this into an array. Okay, so if I run this code out, so this is array 1. Imagine it in this manner. Similarly, let me also create a different array. So let's say array 2. Okay, so array 2. So I'll keep the same set of elements so that it is easy for us to understand this part, right? Okay, so here I have two arrays now. Okay, now if I give L1 into L2, one question, what do you think the output of this is going to be? Are we going to multiply? Remember, matrix multiplication is something different, right? So that is, you're multiplying each row with all the columns. But over here, if I execute this, what is it actually performing? What is the output which you are able to notice? It is just multiplying element to element. That is 1 into 1. The result of that is stored over here. Similarly, 2 into 2, 4. 3 into 3, 9. 4 into 4, 16. That is what it is actually trying to store. But one question, do we actually multiply a matrix in this manner?
No.
No. How do we multiply? So it is something like this, right? So just a quick recap. So I have these two matrix. So matrix 1 and matrix 2. If I want to multiply these two matrix, how do we multiply? So capture one row, multiply with all the columns, right? So for example, let me do this manually for the first time, right? So 1 into 1. What is the output? That is 1. Plus, what is the second thing? What do we do multiply? Is it 1 into 3 or 2 into 3? Quickly. 1 into 1 is done. After that,
2 into 3.
2 into 3, right? So 2 3s are 6. Okay, so plus 6. Okay, now again, this is done, right? So this row and this column is done. Now again, same row with the second column. Okay, so 1 into 2, what will be the output? 2. Plus, what is the second value? What will be the second number? 2 into 4. 4 2s is what?
8.
8. Okay. Then again, second row with first column, right? So 3 into 1, 3. Plus, then again, 4 into 3 is what? 4 3s are
12.
12. Okay, I'm the worst person in mathematics, guys. Please help me out. Now, 3 into what? 3 2s are
6.
6 plus. Then again 4 into 4,
16.
16. Then again over here after this one, right? So up to here, I hope everybody is clear, right? Then after this, just perform the additions. So 6 plus 1, 7. This is 2, 8. What is the value? 10. Here, what will be the value? 15. What is the value over here?
22.
22. Right? So this is how we actually perform matrix multiplication, correct? But what is this output over here which we are receiving? We are getting just element to element wise multiplication. Now the question is, how do we actually receive this matrix multiplication? What is the syntax? How can I achieve this part? Very simple. L1 dot is the function for this to use L2. So run this code out. The output which you are able to see on the right hand side, notice I'm able to achieve it over here. Clear, everyone?
Can you explain once? Just explain.
Okay. Let me quickly recap this one. Okay, right? So now I'll just take L1 and L2. I'll take these two things again. Okay, so but now I'll do one thing. I'll just change one thing. I'll take that is 5, 6 as well. Okay, so this is the matrix. What is the shape of this particular matrix? Anyone? Shape of L1. Shape of L1. You have the output over here.
3 into 2.
3 rows. How many columns?
2 columns.
2 columns.
Two
Okay,
columns.
so if yes. Now in this case, in L2, what is the shape of this matrix? 2 rows?
2 columns.
2 columns, right? Okay. First question, is matrix multiplication actually possible? Yes or no? So basically what I'm trying to do, 3 into 2, 3 cross 2 matrix. I'm trying to multiply this with what? 2 cross 2 matrix. Okay, so is the matrix multiplication actually possible?
Yes.
Answer is yes. How can I tell that? Okay, it is possible, because if this particular number of this one over here, number of columns should be equal to the total number of rows. If these two numbers are same, the answer is yes, it is possible. But by chance, if the matrix was something like this, and I don't have the matrix right now, but again, imagine, is this matrix multiplication possible? No. If the matrix is something of the shape of like this, is this possible? The answer is no. When is it possible? Is the number of columns in one row is equals to the total number of rows in the second row. What will be the resultant shape of the matrix? The shape of the resultant matrix is going to be, in this scenario, in this case, that is
2 into
3
2.
2,
3
3
by
cross 2, right? Okay, so this is how we calculate matrix multiplication. Okay, another scenario I'll take. I have 10 rows and I have, let's say, 15 columns. Imagine it, right? So I'm trying to multiply this with a matrix with 15 rows and 2 columns. Okay, first question, is matrix multiplication possible? The answer is yep, it is possible. What will be the resultant shape of the matrix? That is 10, that is this value. Notice this cross this. Okay, so 10 cross 2. Okay, so this is how you calculate matrix multiplication is actually possible or not in that particular data. Okay, now step 2. Yes, okay, now it is possible. Now, but how do we actually multiply the matrix? Now let us now quickly try to recap it. So it's pretty simple. How do you calculate, or how do you perform multiplication of a matrix? So each row you multiply with all the columns. Let's say when there are 100 columns also, no, you keep on multiplying it, right? So each row you multiply with all the columns. Okay, now if I'm doing it manually, how will I do it? Okay, so pretty simple. Now see, I'm just capturing this row and this column now. Okay, now focus on only one row and one column. You'll get a clarity, right? So 1 into 1, that is 1 plus 2 into what? 2 3 is 6. Okay, so that is 6. Done. Okay, this row, this column, multiplication done. Same row with the second column now, right? So in this case, what will be the output? So that is 1 into 2, that is 2, plus 2 into 4. 4 to is what? It is 8, correct? Okay, now again 3. Okay, this row multiplied with all the columns, right? So even if there are 100 columns, I would have multiplied like this again and again, right? But over here, I just have only these 2 columns. Okay, now second step. Now second row. Now focus on this row with all the columns, right? So 3 ones is 3.
3 plus 12.
Plus 12. That is 12. Okay. So then again, this same row with the second set of column. What will be the outputs?
6 plus 16.
6 plus 16. Okay. So ignore my handwriting. It's very difficult to write in laptop. Then this row with all the other columns. Okay. That is
5 plus 18.
5 plus 18. Okay. Then again, this row with the second column.
10 plus 24.
10 plus 24. Clear, everyone? Now, what multiplication which we actually did over here?
Matrix.
Right. Okay. Now perform the addition. Okay. But in case of you are doing using NumPy, is it really required for me to calculate all of these things? The answer is no. L1 dot of L2. Run this code out. You have the matrix multiplication displayed. Clear? Okay. What is direct option which it is performing? Directly, if I'm giving into, what will it give you? It will give you the element to element wise multiplication, like how it has happened over here. No, so that is 1 into 1, 2 into 2, 3 into 3, 4 into 4, right? So that is what it is happening over here in this case. But if you really want to perform matrix multiplication, you'll be using the function dot over there. Clear? Okay. Now, okay, so I'm just giving this examples. You can even perform division, guys, right? So you can floor division, exponent, everything you can perform it over there. There's no limitation at all. You can perform all the mathematical operations directly. Okay, now, but what if I want to achieve outputs like min, max, sum, right? So product of all the elements, all of this type of outputs, how can I achieve it over there? Here you can use your universal function. Okay, inside universal function, you also have statistical functions as well, right? So you have min, you have your max, you have your sum, you have your add, you have your multiply, etc. I'll try to take you through them one at a time, right? If I want to perform, for an example, let's say min, or let's say I'll take sum of all the elements, right? So let's try to understand this. How do we actually do it? I have an array. Okay, so np dot arrange. I'll take very simple 12 elements. I'll multiply this all of this to the power of 2. Let me show you the output. Okay, here you have the output. Here you have the output over there. Okay, or else I'll keep simple array. Okay, I have an array over here. Now, this is one dimension data, correct? So what dimension data it is right now? It is one dimension data. If I want to get the sum of all the elements, you have core Python function sum as well. You can use that as well. Or else you can also use np.sum as well over here. Okay, so np.sum of A. This is possible. So for one dimension, notice there's no change. You can use any function. But the problem comes when we are dealing with multi-dimension data. Means what? Let's over here, I'll just reshape this to, let's say over here, 2 cross 6, right? So 6 comma minus 1. Okay, I have this particular array. Now, the question is, will your core Python function work over here? What is it giving you as an output? What is the output which I am able to see? Is it giving you the sum of all the columns, or sum of all the rows, or sum of all the elements? Our core Python function. Column wise, right? So that is 0 plus 2 plus 4 plus 6 plus 8 plus this one, correct? So sum of this column, sum of this column, right? So that is our core Python function. But what if I want to achieve the sum of all the values? So means what? So 0 plus 1 plus 2 plus 3 plus 4 plus 5, sum of all the values. How can I achieve it? Here, in case of NumPy, np.sum function will give you this by default sum of all the values. It will by default give here, see, here by default it will not break down column wise, row wise and all. Here it will give you the sum of all the values. Okay. Now I have a different task. Here you have the sum of all the columns. Awesome, it is working fine. But if I want to sum of all the rows, what will you do in this case? Means what? I want 0 plus 1, 2 plus 3, 4 plus 5, 6 plus 7. Basically, row wise sum addition, sum of all the values. How can we achieve it in this case? Okay, so see, in case of NumPy, it becomes very simple. You need not do transpose, etc. at all. Directly, you have an option. Okay, so there is one parameter which I'm going to introduce now. The same parameter is applicable in all the function guys. Okay, so if you press Shift Enter, there is one thing, something called as axis. I want you guys to focus on this axis right now. By default, the value of your axis is what right now is as 0. That's why it is giving you sum of all the values. Okay, now if you change this axis, okay, so that is axis is equals to, okay, so in this case, if I am giving, let's say by chance 0, okay, now 1 second. So if you see axis by default, it was none. I'll show you the array over here in the below hand side because it is becoming difficult. Now what do we have? If I change the value of your axis as 0, now you will have what? So sum of all the columns. So now you tell me logically, if I want to have sum of all the rows, how do you think I need to achieve? What do you think I need to change?
Different value for axis.
Axis is equals to 1. Axis is equals to 1. So this is how you can achieve this particular part. So sum of all the rows, basically what output? 0 plus 1, 2 plus 3. That is what you are able to see as an output. So like this, you can play around with our data again. By default, all the functions will give you axis as 0, axis as none. If you want row wise separately, column wise separately, please play around with the axis. But do not by heart this axis value. Why? Do not by heart the axis value telling that, okay, 0 means every time it is going to be columns. 1 means every time it is going to be rows. No, that is not the scenario. In NumPy, at least in Pandas, they corrected this issue. But this NumPy has this problem. In some of the functions, axis means for columns, axis means for rows. It will change, guys. Do not fix that, okay, every function it is going to be same, right? Please do not fix this. Do a trial and error method and then test it out. Okay, so it will change. Remember this point. Done. Now, like this sum, if you want, you can get anything. So let's say over here, that is np.min of the data, right? So min of A, by default, min of the complete data. If you want, axis is equals to whatever it is, axis is equals to 1, column wise or row wise, right? So at least whatever it is, you will be able to see this particular values over there. Like this, you can play around. So min function, direct straightforward function to get the min of all the elements. Max of all the elements. Now add is there, subtract is there, we have multiply, and then we have statistical functions also. Let's say something called as mean, median, and mode. You don't have this in case of NumPy, you have it in case of Pandas. Okay, now let me show you this as an example, and then I'll come to this part. Okay, this is one category. Here the output is single value. Unary functions is what we refer to as, right? So that is what a function which will return one value as an output. But we have another functions also, that is okay, so that is something like this. I'll copy this one here. This is the data. What are we performing? We are performing plus. Okay, so here we are performing the addition of these two arrays. Okay, now in this syntax, if I want, I can also not just two, you can also add multiple arrays also in a single shot. Correct? So let's say something like this, right? So something like this. Let's say over here, I'll just change the elements. This is 10, I'll take this, I'll take it as 20, 30, 40, and 50. Okay. Now, not just these two things. If I want, I can even process multiple arrays as well, right? So that is what 1 plus 6 plus 10. That is the output which I'm able to see over here, correct? Now, the same addition you can also perform by our universal functions as well. Okay, universal function. For now, I'll comment this out. I want to add L1 plus L2 element to element. You can also achieve this task by this function. Okay, so if I press Shift and Tab, but notice X1 and X2, you can process L1 and L2. I'll run this code out. Notice element to element addition I am able to perform. But the advantage of doing this is the speed is actually faster, more faster than performing directly. More faster than performing directly. But there is a drawback in all of this. So for addition, it is add. For subtraction, it is subtract. For multiplication, it is multiply. For power, right? So we have a power function. Product function. Everything is present, right? So all of these operations, you directly have this universal functions as well. But the limitation is all of this is you can only process until 2 arrays at a time. The third array, what you will provide like this, is something else. Press Shift and Tab. The third parameter, see, these are two inputs. The third parameter is basically what? It is the output, correct? So it is the output. So what it will do now, in this case, it will do what? So basically the addition of these two arrays, the result of that, it will be dumping it inside this particular array. So if I run this code out and if I'm trying to now print the L3, notice something. Previously I had this value, right? So now notice it has changed. So if you're using universal functions, you can process two arrays at a time. And the third input, what you will provide is the output of that particular array. So we actually use this in what I showed you in that scenario, no? So basically we do what? So we replicate np dot zeros, like we'll copy the shape of an existing array. That is not A, that is L1, right? Okay, so we copy the shape and then we basically I did what? So L3, if I'm trying to print. So I created an array, filling the elements, basically creating a dummy column. And then result of these two things, I'm storing it over here. That is what I'm trying to perform over here, right? So this can be used in this scenario. So addition of these two, the result of that will be dumped in L3 over there. If you want, you can only process two arrays at a time. The outputs are actually faster. But if you really have multiple arrays to process, please do it in this particular syntax. Clear? Okay. Last two functions and then I'm going to stop this, guys. Okay, I know you guys might be fed up right now, but again, just hold on. Last two functions, that's it. That is mean and median. I'll just do it and I'll close it. Mean, okay. Mean is basically what? What is the meaning of mean? Any idea? Mean means what?
Average.
Average.
That is nothing but our average, right? So averages, let's say over here I have some data. For an example, let's say I have some data like list is equals to some random value. Let me just take. Okay, so this is the data. If I want to calculate average manually, how do I do it? This list average, I want to
Sum of all the elements, then you have to divide
sum of this list
number of elements
divided by the total number of elements. This is how we calculate the average of the data, right? The same scenario. If I want to calculate the average in case of our what? That is in our NumPy array. So how do we do it? np dot, let's say, array. Okay. Now let's say over here, same thing. I have an array. I want to calculate the average of this particular array, right? So how can I do it? np dot mean, and I can provide this particular list. Okay, so if I press shift enter, now run this code out, you'll be able to get the average. But yeah, we can calculate it manually as well as over here as well. The advantage is this, using this particular case is what? The advantage comes into picture if you are dealing with what? Let's say if you are dealing with multi-dimension data. Okay, now if I have this, now you guys help me out. This will give you the average of the complete data or average of each rows or average of each columns.
Complete data.
Complete data. Right, so here you have the complete data. Now if I want to have the mean of each row separately, mean of each column separately, how can I do? Access is equals to 0. This is giving you for each columns. Similarly, if I give, let's say, access is equals to 1, it will give you the average of each row over here. That is the average here. Simple. Now what is mean? Sorry, median. What is median? What is the difference between mean and median? I have an age data.
Middle element.
Exactly. That is a middle value, right? So imagine this case. You have a data. So you have some data for age. So something like this, something like this, something like this. I'll just take some examples for me to explain. So totally how many elements? 1, 2, 3, 4, 5. Okay. 5 elements are there. If I want to calculate median manually from my side, what is the method of calculating? How do I calculate? There are two steps. Is this, one second, is this the median of my data right now?
Yes, the element at the middle position.
Yeah. First step is you sort the data in either ascending or descending order, correct? So if I want to do it in case of our core Python, what is the function which I can use? Age dot
Sets also you can.
Sort by default it is sorted data into ascending order, correct? So now sorted the data into ascending order. Okay. After sorting the data, capture the middle value. See, this 23 is the middle value. Left hand side 2 values are there, right hand side 2 values are there, right? So now this will become my median of the data. Okay. So, but okay, so here the number of elements were what? It were odd. What if, let's say, the data is like this? Now what will be the average of the, sorry, what will be the median of this data? How do I calculate it? Capture the middle two values, mid two values, and take the average of that. That is what? 19 plus 23 divided by 2. Run this code out. This is how you calculate the data median for this type of data. Okay, now the same thing if I'm trying to do it with our what? That is our NumPy array. How do I do it? How do I achieve this task? So np dot array. Okay, so that is np dot median of this age. Okay, so run this code out. See, this was the median, correct? Notice this was the median. Similarly, in this case, 21.0, right? Let's see it. So over here, if I just remove this value, 21.0 will be the median. This is how you calculate the median for that particular data. Clear, everyone? Okay, I'm going to stop for now then, guys. Okay, so I'm going to stop going with the new topics. Let us work on some of the tasks. Okay, so let us work on some of the tasks. But for this now, actually, I wanted to do this operations directly in our pandas, but again, let's do it right now and then let's proceed, right? I'll load some data. One second. I'm inside this one. Just a minute then, guys. Okay, I'll actually boot us some data. I'll share it to you guys, and then let's work on it. But for this, I want you guys to take some smaller data set. After this, I think whether I have to take this one. I'm just taking a small data set so that we all can work together again. Okay. So, but I'll share you this data. Okay. Quickly. I've shared the data in the chat box. Can you guys copy this one? Let me know if you're able to see a table like this quickly.
Can you please explain the codes also? Like it's a bit new.
For which one?
This code like df equal to pd dot data frame.
This one, pandas, when we go right, Arunima, then we'll understand this.
Okay.
Because pandas right now I don't want to start. Many things in NumPy is still pending. After that, if we go to pandas, it will make sense. Okay, just copy and paste this code. See if you are able to see this data together. This code explain I will not be doing right now because we'll understand this from depth. Why this function, what are all the parameters and everything. I'll explain this in depth.
I'm getting error as that no module named pandas. So it's because I did not install that NumPy.
Remember? No. Remember any module, you have to first do what? So pandas space py. So you have to install this one, right? So run this code in your terminal once. Hit install pandas.
Okay. So what
And
is that command? What should I type? Pip.
Just copy this one. Pip install pandas and run
Okay.
this. Any library from now onwards, like how I told now, these libraries will not be present in your systems. Okay, so what you have to do is you have to install all of these libraries, right? So, but again, how do we install it? So any library, let's say over here I want to install, let's say in this case, if I want to install Cborn, right? So Cborn space pypi, search for this one, okay, in your Google, right? And then open the first link, pypi.org, whatever link which you get over here, just copy it and install it. Okay, so is it done?
Yeah.
Okay, now very simple, guys. Step one, remember one thing, pandas is built upon NumPy. Remember the point, pandas is built upon NumPy, just a method of beautifying the data, that's it. Okay, but again in the backend, whatever things which we are learning in NumPy, same things continue in pandas. Okay, just some more advantages are there, we'll come to that one. Okay, task one, very simple task. Okay, so what exactly is happening is, this is one array. Remember this point, see, this is a multiple arrays combined together. This is one array, this is one array, and this is one array. Okay, remember this is how the data is actually mapped in together in the back end. Okay, a small thing what I want to achieve is I want to just multiply these two things into, basically I want to multiply 32 into 6, 35 into 7, this into this one. That is my target. Okay, so that is what I want to achieve. Like how we had stored directly an array into a variable. No? If you want to access this array, what you have to do is you have to df, like a type of a dictionary of that particular column name. Similarly, if I want to capture this particular array, df of this particular column, this is how you capture that particular data, that array. Now, give me a code that will perform the multiplication element to element, right? Simple, it should be very simple. Okay, I'll do this one from my side. Then you guys do the second task, guys, because as a syntax level, you need to have a reference as well, right? Very sorry. This one, if you want to perform, okay. So try to recall the topic which we just covered over here. Okay. So this one which we covered, no? This one which we covered. So I just wanted to perform element to element multiplication. So I can, or addition, right? So something like this also I can achieve it directly, correct, no? Here, in case of arrays, you perform the operations directly over there. So same thing, this is also an array. So I have a simple question for all of you guys. Can I do it like this? Will it give you concatenation or addition over here? Wait, I'll just perform this. Addition or concatenation?
Addition.
Addition.
It will give you the addition of this particular data, that is element to element wise. That is what 32 plus 6, 35 plus this one, this plus this one. That is what your output which you are able to see. Clear? Okay. Step 2. Okay, so the task is very simple, right? So what I want you guys to do is, okay, so help me to extract the mean of this particular temperature column. Mean of the temperature column. How you do it, I don't know. But use.
You had asked to multiply two columns, right? Before.
This one.
So that's addition, no? Plus.
Oh, sorry. Okay. Multiplication. Yeah, but I wanted a comparison. But yeah, multiplication. So the thing is, any mathematical operation directly you can perform it.
So it threw me an error, so I was just checking. Can you please run it with star once?
See, 32 into 6.
Okay. Yeah, thank you.
Mean of
but
temperature
this needs
column.
to be of same data type, right?
Yes,
Right.
that is the rule of NumPy itself. Everything should be
Yeah.
same data type. But if somewhere some data type changes, then God, you have to first clean the data and then come back to perform this operation.
Okay.
It's of the same data set df. So can't we do just df of temperature into wind speed? Means df of temperature multiplied by df of wind speed we are doing. So in syntax, it's just df of temperature multiplied by wind speed.
That's it. How come? Because in the backend it is prepared in NumPy. What is the syntax of perform?
No, I'm saying, can we ignore the df at wind speed?
No. That you cannot do it. That is how you extract the data in case of pandas. No, that you cannot. You mean to tell only temperature into wind speed?
No. df of temperature into wind speed.
No, that will also not work.
So this, like, what I have done is like df temperature converted into arrays using NumPy and then taken a mean. So
yeah, but that is you. If you want, you can do that. But lengthy method. By default, it is actually an array itself.
okay, so when you say data frames, automatically it's an array only.
Yes, combination of arrays together. That's it.
Okay, so all the NumPy functions will work on df without converting that to array.
Exactly, it will work because it is built upon NumPy.
Okay.
So yeah, mean. How do we do it? Let's say if I want to do mean, right? So we took this as an example. So where is it? Here, mean. See, np.mean. Here we can go ahead and we can take it. Right. So directly it will give you the mean of all the elements. So anyhow, this is one dimension data. This is one dimension data which is mapped to this particular column. Right. So if I wanted to mean df of temperature, I'll first capture this particular column, and then again this will be what? So np dot mean of this particular values. Run this out, you'll be able to get the output over here. Clear? Very simple, right? Okay, now see, I cannot go to complex scenarios. I cannot show you guys directly. I cannot split this data. I cannot concatenate this data at all because those things are pending. But again, anything related to mathematical operations, I'm trying to perform. Okay. Remember this point, guys. Okay, so this point plays very vital role
Nice.
to create a column.
One more thing before you proceed. So when I did np.mean and df temperature, it's giving me np.float 64 and then 30.33.
Can you paste np dot mean
df temperature?
So
the value I am getting same 30.33, but before that it is saying me np.
You are able to see the data type as well over there?
Yeah, like this one.
Okay. So I think the newer version which you might have installed now,
Okay.
those might display this one, but
Oh.
yeah, that depends on version to version as well.
Okay.
Okay. Now what I want to achieve is pretty simple, guys. Okay. Now look at this one now. One second, I'm just thinking. Okay, let me show you the syntax first, and then I'll come to the task. Okay. If I want to, my target is to do what? If I want to initialize a column with zeros or ones, how do I create a column, right? So yeah, this in depth I will go, but again, if you want to create a column, let's say I'll just give col_1 here. I'll just initialize this particular columns with filling the values with what? Let's say zeros. Okay, so zeros, like, so that I can copy existing this one over there, right? So now if I run this code out, notice I have initialized a column filling the elements with what? Zeros over there. Okay, this is the syntax. Now I want you guys to do one thing. Now the task over here is, remember we did this just few minutes ago. Addition of these two things, 32 plus 6, I want to store the results over here. How you do it, it's your wish. Addition of 32 plus 6 is, the result should be stored over here. Okay, I'll show you the reference what I'm talking about. It is right somewhere over here. Which function, guys? Somewhere over here itself it is there. I'm able to see it in my screen. Yeah, that is a
Add
Krishna, what
L1,
you
L2.
This one, right? L1, L2, and
Yeah.
then the third column name, dumping column name, right? This is the output. Okay, so let me just copy the same thing. Krishna, that's correct. What you have done is correct. But that is the syntax of pandas actually. Okay, so but I want to be with NumPy for some time. That's why. So like this is a syntax, guys, right? So if you guys have done it, I'll just copy it and I'll paste it.
Dot add temperature plus wind speed.
And this is the column underscore 1. That is our df of column underscore 1. Run this code out, and now if I run this over here, notice what has happened. Something has happened. That is, the result of these two things has been dumped inside this particular column. Like this, we can play around. Clear? Okay, so what did I do in this classes? I showed you guys how to create arrays, how to change the shapes of an array, and then basic mathematical operations. That's it, guys. Remaining parts will continue in tomorrow's class. Done? Okay. And I know you guys might be thinking for practicing, right? So for basic, this ones and all, we'll do it in pandas is what my thinking is. That's why here I don't want to practice much, because in pandas, no, when you're dealing with an actual data, that's where you can practice a little bit more. One last question before wrapping up. Help me to convert this data into interchange. Basically, I want this day as a column. This rows into columns and columns into rows. Basically, this should be the index value, and the complete row should contain the dates. Temperature, the complete row should contain the day temperature records. So basically, can you help me to convert this into rows into columns and columns into rows? Which concept is this? df dot what?
T.
transpose.
Transpose. Okay, so this is how we play around with the data over there. Okay. But again, some more problems will do it, but I'll plan to do this in pandas directly. Is that okay? Okay.
Give us some time, like when you finish some topic to just execute, and then it'll be helpful more
Okay, then.
to
Okay.
understand. Like even we will practice at the same time itself.
Sure, done. Sure, done. Done, Vinay. Okay, so then I'll reduce my speed a little bit more tomorrow's class, guys. Okay, so I'll give you guys more time to practice it. Done? Okay, so see you guys tomorrow. Have a great day.
I need
Please
one
share
help.
the
Can you
notebook
please
here.
stay back?
This notebook, yeah, I'll share it with Chris. I'll share it with Karthik. He'll upload it in your drive link. Done? Okay, then good. Thanks for joining. Bye.
I need one help. Can you please stay back? I just want to share my screen and show you things are not working for me, so I just need help there.
Sure, Bhavna.
Yeah, thank you.
Okay, then guys. Others, if you guys have no questions, you guys can drop it. Bye. Thanks for joining. Bye.
Hey, thanks for the nice session. Thanks.
No worries. No, thanks for attention.
Thank you.
Thank you.
Yeah, I'm sharing my screen. Let me know once you're able to see my
But I'm only
screen.
able to see your terminal.
Yeah, terminal only I'm sharing. So
okay.
here I did this pip install pandas. It says this. Okay, it means it is already installed, right?
Exactly. Yes.
But when I'm running it now, I have to reshare 1 second.
Yeah. Share the complete screen directly.
So when I'm running notebook, yeah, I'll share the complete screen. Let me stop it now. How to stop? Yeah. Complete screen. Yeah, share. Oh, it's still again. Stop share and then again. Are you able to see my whole screen? All
It's loading. It's loading. Yes, I'm able to see it.
Are you able to see my notebook?
Can you go to the notebook? No, not yet.
Chrome means, yeah, in Chrome I have opened the notebook.